Hey everyone, and welcome back to the channel. Are you tired of soaring electricity bills? Do you dream of energy independence? Well, today we're diving deep into the world of solar power, specifically how to set up your very own 5 kilowatt hybrid solar power system. This isn't just about saving money, it's about taking control of your energy future. A 5 kilowatt hybrid system is fantastic for medium-sized homes, typically generating around 20 units of electricity per day. What makes it hybrid? It means you get the best of both worlds. You can draw power from your solar panels, from batteries, for off-grid use, or during outages, and even from the utility grid when needed. Plus, you can often sell excess power back to the grid. In this video, we'll break down every component, their specifications, and a step-by-step wiring guide. Let's get started. The heart of the system: solar panels. First up, the stars of the show, your solar panels. For a 5 kilowatt system, you'll typically need around 12 to 17 panels, depending on their individual wattage. We recommend high-efficiency monocrystalline panels for their performance and durability. Specifications to look for. Type: monocrystalline silicon is generally preferred for its higher efficiency, typically 18 to 22%, and better low-light performance. Power output: individual panels typically range from 350 watts to 450 watts, or even higher. For a 5 kilowatt system, if you choose 400 watt panels, you'd need 5,000 watts divided by 400 watt panel equals 12.5 panels. So you'd round up to 13 panels. Open circuit voltage, VOC. This is the maximum voltage a panel produces when not connected to a load. Important for string sizing. Short circuit current, ISC. The maximum current a panel produces when short-circuited. Maximum power point voltage, VMPP, and current, IMPP. These are the voltage and current at which the panel produces its maximum power. Your inverter's MPPT range needs to match this. Temperature coefficient. This tells you how much a panel's output decreases with rising temperature. Lower is better. Dimensions and weight, crucial for planning your roof space and mounting structure. A 400 watt panel is usually around 1.8 meters by 1.1 meters, so 13 panels would require roughly 25 to 30 square meters of roof space, including spacing. Wiring configuration, series versus parallel. Series connects panels end-to-end, positive to negative, to increase the total voltage, ideal for long cable runs and to meet the high voltage input requirements of most hybrid inverters. If one panel is shaded, it can affect the entire string. Parallel connects panels side by side, positive to positive, negative to negative, to increase the total current while keeping the voltage the same. Better for systems with potential shading, as each panel operates more independently. Series parallel. For a 5 kilowatt system, you'll likely use a combination. You'll create strings of panels in series to reach a certain voltage and then connect these strings in parallel to increase the overall current and total power. For example, if your inverter has an MPPT range of 120 volts to 450 volts and your 400 watt panels have a VMPP of 40 volts, you could put 8 panels in series to get 8 multiplied by 40 volts equals 320 volts, which falls within the inverter's range. Then, you'd have 2 of these 8 panel strings in parallel to reach 16 panels multiplied by 400 watt panel equals 6,400 watt total PV array, providing some headroom. Or, for a 5 kilowatt system, you could aim for a slightly smaller array, like 2 strings of 6 panels each. 12 multiplied by 400 watt panel equals 4,800 watt or 4.8 kilowatt. Always refer to your inverter's specifications for optimal string sizing. Segment 2. The brains. Hybrid inverter. Next up, the brains of your solar operation, the hybrid inverter. This is where the magic happens. Converting the DC power from your panels into usable AC power for your home. Managing battery charging and seamlessly switching between solar, battery, and grid power. Key specifications for a 5 kilowatt hybrid inverter. Rated power output: 5,000 watts or 5 kilowatts. Continuous output: this is the maximum AC power it can supply to your home. Surge power often double the rated power for a short duration, 10,000 volts amps for a 5 kilowatt inverter, allowing it to handle sudden power demands from appliances. MPPT voltage range, maximum power point tracking. This is crucial. It tells you the optimal voltage range for your solar panel strings. For example, 80 to 500 volts. Ensure your panel string voltage falls within this range. Max PV input power, the maximum DC power the inverter can handle from your solar panels. For a 5 kilowatt inverter, it might be 6 to 7.5 kilowatts, allowing for oversizing your solar array for better production in low light conditions. Battery voltage. Common options are 48 volts. This must match your battery bank's voltage. Max charging. Current. How fast the inverter can charge your batteries from solar or the grid. AC output voltage and frequency. Typically 220 volts/230 volts. AC at 50 Hz for most regions. Pure sine wave output. Essential for protecting sensitive electronics in your home. All good hybrid inverters offer this. Communication ports. For monitoring Wi-Fi, Bluetooth and RS-485, and often for communication with smart batteries. Parallel functionality. Some inverters allow multiple units to be connected in parallel for future expansion, increasing total power output. Inverter placement. Choose a cool, dry, well-ventilated area, ideally close to your main electrical panel and batteries to minimize cable runs. Ensure it's easily accessible for monitoring and maintenance. Segment 3. Energy storage. Batteries. Now let's talk about storing that precious solar energy. Batteries. This is what makes your system truly hybrid, providing power during the night or when the grid goes down. Battery types and sizing for a 5 kilowatt system. Lithium-ion LiFePO4 are top recommendation. They are more expensive upfront but offer a longer lifespan, thousands of cycles, higher depth of discharge (DOD), faster charging, and are virtually maintenance-free. For a 5 kilowatt system, a common size is 10 to 15 kilowatt hours of usable capacity, which could mean a 48 volt, 200 to 300 amp hour battery bank. Lead acid gel AGM flooded. A more budget-friendly option, but they have a shorter lifespan, lower DOD, typically 50%, and require more maintenance, especially flooded lead acid. For a 5 kilowatt system, you'd need a significantly larger capacity, 20 to 30 kilowatt hours total capacity to get 10 to 15 kilowatt hours usable, and careful ventilation. Sizing your battery bank. This depends on your daily energy consumption and how much backup time you need. A typical home might use 15 to 20 kilowatt hours per day. For a 5 kilowatt system, a 10 to 15 kilowatt hour battery bank often provides adequate overnight power or several hours of backup during an outage. For example, a 48 volt system with 10 kilowatt hours of usable energy, 10,000 watt hours divided by 48 volt equals 208 ampere hours. So a 48 volt 200 amp hour battery bank would be a good starting point. Wiring configuration, series and parallel for batteries. Batteries are typically connected in series to achieve the desired system voltage. 4 12 volt batteries in series for a 48 volt system. Multiple series strings can then be connected in parallel to increase the overall amp hour capacity. Important, always use batteries of the same type, age, and capacity when building a bank. Segment 4. Safety first. DC breakers and isolators. Safety is paramount in any electrical installation and solar is no exception. DC breakers and isolators are your essential guardians. DC breakers for batteries. These are vital for protecting your battery bank from overcurrents and short circuits. Placement. Usually located immediately after the battery bank before the inverter's battery input. Specifications. Voltage rating must match or exceed your battery bank voltage, 48 volts DC or higher. Current rating, sized based on the maximum charging torque discharging current of your batteries and inverter. For a 5 kilowatt inverter with a 48 volt battery bank, the maximum current drawn from batteries can be 5000 watts divided by 48 volts equals 104 ampere approximately. You typically choose a breaker rated slightly higher, like 125 amps or 150 amps, depending on the inverter's specs and cable sizing. Type: DC rated circuit breakers, MCBs or MCCBs, specifically designed for DC circuits. DC isolators, PV disconnects. These devices allow you to safely disconnect the solar panels from the inverter. Placement. Located between your solar panel array and the inverter's PV input, often found in a DC combiner box. Specifications. Voltage rating. Must be rated for the maximum open circuit voltage of your entire solar array string, 500 volts DC, 800 volts DC, or 1000 volts DC, depending on your array design. Current rating must be rated for the maximum short circuit current of your solar array, 20 amps, 30 amps, 50 amps, depending on string current. Load break rating, capable of safely disconnecting under load. Enclosure rating, IP65 or higher for outdoor use to protect against dust and water. Why are they important? They provide a crucial safety point for maintenance, troubleshooting, and in case of emergencies, allowing you to completely de-energize the DC side of your system. Segment 5. The veins and arteries, wires and AC/DC DBs. Think of wires as the veins and arteries of your solar system, carrying power where it needs to go. And the AC and DC distribution boxes, DBs, are like the junction points, protecting these critical pathways. Solar wires, Lloyd-short cables, PVDC cables, specifically designed for outdoor solar applications. They are UV resistant, weather resistant, and can handle extreme temperatures. Sizing, crucial for minimizing voltage drop and preventing overheating. Use online calculators or consult your electrician. For a 5 kilowatt system, common sizes for PV strings might be 4 mm squared to 6 mm squared, 10 to 12 American wire gauge. For longer runs or higher currents, thicker cables like 10 mm squared or 16 mm squared might be needed. The general rule is to aim for a voltage drop of no more than 2% of the system's voltage. Color coding: red for positive plus, black for negative minus. Battery cables: very thick flexible copper cables designed for high DC currents. Sizing: dependent on battery bank voltage and inverter power. For a 5 kilowatt inverter at 48 volts, the maximum current is around 104 amps. You'd likely need cables like 35 mm squared or 50 mm squared, 20 American wire gauge or 0 American wire gauge for short runs, possibly larger for longer distances. AC cables, standard electrical cables used for connecting the inverter to your home's main distribution board and the grid. Sizing of the critical components in both your AC and DC distribution boards for a 5 kilowatt hybrid solar system. General principles for sizing: continuous load. For circuit breakers and fuses, you typically size them at 125% of the continuous current they are expected to carry. This accounts for thermal derating and prevents nuisance tripping. Maximum current. Always consider the maximum possible current. Short circuit current for PV, surge current for inverters, maximum discharge current for batteries. Voltage rating. Ensure the component's voltage rating is higher than the maximum voltage it will experience in the circuit. Type. Use components specifically rated for DC or AC as appropriate. DC distribution board, DCDB, components. The DCDB primarily handles the power coming from your solar panels and going to your inverter. DC surge protective device, DCSPD, purpose: protects the inverter and solar panels from voltage surges caused by lightning strikes or other electrical disturbances. Voltage rating, UC/MCOV. This needs to be greater than the maximum open circuit voltage, VOC, of your entire solar panel string. For example, if you have two strings of 8 times 400 watt panels in series, each with a VOC of 48 volts, your string VOC is 8 times 48 volts equals 384 volts. You would likely choose an SPD with a UCMQOV of 600 volts, DC or 1000 volts DC to provide sufficient headroom, as actual VOC can increase in colder temperatures. Nominal discharge current in typically 20 kiloamperes for residential systems. Maximum discharge current IMAX, often 40 kiloamperes. Type usually type 2 for typical residential PV installations. Some systems may also incorporate a type 1 SPD at the point of entry for direct lightning protection. Poles, usually 2-pole for positive and negative lines. Quantity: 1 SPD per MPPT input of your inverter if your inverter has multiple MPPTs. Or, if using a combiner box for multiple strings, 1 SPD for the combined output. DCMCBs, miniature circuit breakers. Purpose: provides overcurrent protection for each solar panel string, allowing for isolation of individual strings for troubleshooting or maintenance. Voltage rating: must be rated for the maximum open circuit voltage VOC of your solar panel string, 600 volts DC or 1000 volts DC. Current rating: sized based on the short circuit current EZ of a single solar panel string. Calculation: ICB equals ESC subscript string multiplied by 1.25 for continuous current as per NEC guidelines. For a 400 watt panel with an ESC of say 10.5 amps, a single string will have 10.5 amps. So 10.5 amps multiplied by 1.25 equals 13.125 amps. You would round up to the next standard breaker size, typically 15A or 20A DC. If you have two strings connected in parallel before the breaker, less common in a simple DC-DB, usually each string gets a breaker. You'd sum their ISC poles, typically 2-pole. Quantity: 1 DCMCB per string of solar panels. If your inverter has multiple MPPT inputs, each MPPT input might have its own breaker in the DC-DB. AC distribution board, ACDB components. The ACDB manages the AC power from your inverter, connecting it to your home loads and the utility grid. AC surge protective device, ACSPD. Purpose: protects the inverter and your home's AC loads from voltage surges. Voltage rating UC/MCOV must match your AC system voltage, 230 volts AC, nominal discharge current in, typically 20 kiloamperes or 40 kiloamperes. Maximum discharge current IMAX, often 40 kiloamperes or 80 kiloamperes. Type: usually type 2 for residential applications. For higher risk areas or more critical installations, a type 1 may be used at the main service entrance. Poles: for a single phase system, typically 2-pole or 4-pole if protecting neutral and phase. ACMCBs, miniature circuit breakers. Main AC output breaker, inverter to load grid. Purpose: protects the AC wiring from the inverter to your home's main distribution board grid connection. It also serves as an isolation point for the inverter. Current rating: sized based on the maximum continuous AC output current of your 5 kilowatt inverter. Calculation: for a 5 kilowatt inverter at 230 volts, the maximum continuous current is I equals 5000 watts divided by 230 volts, approximately 21.74 amps. Applying the 125% rule for continuous load, 21.74 amps multiplied by 1.25 equals 27.175 amps. You would typically select the next standard breaker size, which is usually 32 amps AC or potentially 40 amps AC, to provide more headroom depending on inverter surge capabilities and local code. Poles: 2-pole for single phase systems, phase and neutral. Grid connection breaker optional but recommended. If you have a separate breaker for the grid connection for export-import, it would also be sized similarly to the main AC output breaker. Load circuit breakers. These are for individual circuits within your home protecting specific loads, lighting, power outlets, and heavy appliances. Their sizing depends on the connected load and wire gauge as per standard electrical practices. 10 amps for lighting, 20 amps for general power outlets, higher for heavy appliances like geysers or AC units. Your existing HomeDB likely already has these. ELCB earth leakage circuit breaker / RCCB residual current circuit breaker. Purpose: provides protection against electrical shock by detecting leakage currents to earth. Current rating: should be rated for the main incoming AC current, typically 40 amps to 63 amps. Sensitivity: tripping current. For human protection, a sensitivity of 30 milliamperes is standard. Type: for solar applications, a type B RCCB is often recommended. This is because solar inverters can sometimes produce DC leakage currents, which a standard type A or AC RCCB might not detect, making them unsafe. Type B RCCBs are designed to detect both AC and pulsating smooth DC leakage currents. Placement: usually placed at the main incoming supply point in the ACDB or your home's main distribution board. Some hybrid inverters have built-in RCD functionality. Example sizing for a 5 kilowatt hybrid system. Illustrative, consult professional. Solar panels. 13 times 400 watt panels equals 5.2 kilowatt array. Assuming each panel ESK equals 10.5 amps, VOC equals 48 volts. Two strings of 6 panels in series. 6 times 48 volts equals 288 volts. Each string ESK equals 10.5 amps. Hybrid inverter 5 kilowatts 48 volt battery MPPT range 120 volts to 500 volts. Max PV input 6 kilowatts. Max AC output 21.74 amps. Segment 6. Step-by-step wiring configuration. Alright, now for the exciting part, putting it all together. Remember, if you're not comfortable with electrical work, always hire a certified electrician. This is a general guide. Step 1. Mount solar panels and racking. Install your solar panel mounting structure securely on your roof or ground. Mount your solar panels onto the racking system. Ensure proper spacing for ventilation and maintenance. Step 2. DC wiring, panels to DC-DB. Series connections. Connect the positive terminal of one panel to the negative terminal of the next panel in your string. Parallel connections. Once you have your series strings, connect the positive terminals of each string together and the negative terminals of each string together using appropriate branch connectors. MC4 Y connectors. Run the main positive and negative DC cables from your solar array or combiner box if you have multiple strings to your DC-DB. Connect these to the input terminals of your DC isolator or surge protective device within the DC-DB. Connect the output of the DC-DB to the PV input terminals of your hybrid inverter. Step 3. Battery wiring, batteries to inverter. Series connections. If using 12-volt batteries to form a 48-volt bank, connect positive to negative in a series string, 4x 12-volt batteries for 48-volt. Parallel connections. If you need more capacity, create multiple 48-volt series strings and connect them in parallel. Connect your battery bank to a main DC breaker, sized appropriately for your battery current. Run the main positive and negative battery cables from this DC breaker to the battery input terminals on your hybrid inverter. Ensure correct polarity. Step 4. AC wiring, inverter to AC-DB and home load cost grid. Connect the AC output of your hybrid inverter to the input side of your AC-DB. From the AC-DB, connect to your home's main electrical distribution board load side. This supplies power to your home circuits. Also from the AC-DB, connect to the utility grid connection point, grid side, often through a dedicated meter for net metering if applicable in your area. This allows you to draw power from the grid and export excess solar power. Step 5. Grounding. This is critical for safety. Connect the frames of your solar panels to a common grounding wire. Connect this grounding wire to your mounting structure. Run a grounding cable from the DC-DB, the inverter chassis, and the AC-DB to a dedicated grounding rod or your home's main grounding electrode. Important: all metallic enclosures and non-current carrying metal parts of the system must be properly grounded. Step 6. Monitoring and commissioning. Once all connections are secure and verified, turn on the breakers in the correct sequence. Usually DC first, then AC, then activate the inverter. Most hybrid inverters come with a monitoring app or software. Connect your inverter to your home Wi-Fi or network to track production, consumption, and battery status. Perform initial system checks to ensure everything is operating as expected. And there you have it, a comprehensive overview of building your 5 kilowatt hybrid solar power system. This setup empowers you with energy independence, reduced utility bills, and a smaller carbon footprint. Remember, proper planning, quality components, and adherence to electrical codes are vital for a safe and efficient system. If you're unsure about any step, always consult a qualified solar installer or electrician. If you found this video helpful, please hit that like button, share it with your friends, and subscribe for more renewable energy content. Let me know in the comments if you're planning your own solar journey or if you have any questions. Thanks for watching and see you in the next one.